Expand and simplify is the second of 6 algebraic manipulations you can use when evaluating limits algebraically. The strategy for evaluating limits algebraically will be to first try direct substitution. But if that fails, which it often will, we want to think of expand and simplify as one of the tools that can help us proceed in finding the limit. Let me show you an example of how it works. Now, we always try direct substitution first. So I'm going to do that by taking the limiting value, which is 0 here, and plugging it in for every t that I see on the inside of the limit. In that case, I get 0 minus 1 squared minus 1 all over 0. And immediately I see I have a 0 in the denominator. It doesn't even matter what this numerator reduces to, but just to be thorough and complete my sentence, it does reduce to 0 also. So I have a 0 in the denominator, and that tells me that direct substitution is not going to work. I'm going to need to use something different. So what will work here is the technique called expand and simplify. So I'm going to restart the problem by rewriting the limit. So I'm going to say the limit as t goes to 0. Again, I'm rewriting the limit to indicate to everybody that I'm going to try something new, that I'm starting over from scratch. Okay, so what I want you to notice here, we call it expand and simplify because there's going to be something that can be expanded, and that's going to be this part of the numerator, t minus 1 quantity squared. Now, if we recall what that means, for something to be squared, carrying the limit through because I'm not applying the limit yet, I'm just changing the way the inside of the limit looks. So t minus 1 quantity squared is the same thing as t minus 1 times t minus 1. That's the definition of what it means to be squared. So I've literally taken that t minus 1 quantity squared and written it as t minus 1, t minus 1. Now I'll subtract that 1 that's on the end of the numerator, and we're still dividing by t. Okay, so that's the first part of the expansion. The second part of the expansion is to perform the multiplication of those two binomials, and that involves the FOIL method that we all know and love. So it's the first, outer, inner, last. And most of the time when we do our expanding, it's going to be a FOIL of two binomials, a multiplication of two binomials. So let's go ahead and do that. I'm going to carry the limit through because, again, I'm not using the limit operator yet. I'm just changing the way the inside of the limit looks. So going through with that multiplication, I get t squared. That's the first of the FOIL. And then outer minus t, inner minus t, and last gives me plus 1. And then this minus 1 here is going to stay minus 1, and we're still all over t. Okay. So a few things are well, I guess the most important thing here, what's really going to make this all work is that this 1 and negative 1 are going to cancel. And then from here, I can simplify the numerator combining like terms. So I'm going to carry the limit through again, giving me t squared minus 2t all over t. So take a look at that. I'm going to buy myself some more room here by moving down. All right. So now the question is, where do I go from here? I've actually completed the expand and simplify part, and now I'm left with this limit, and I want you guys to see how the numerator, and this is going to bring us back to the previous video, to the previous twist, to the previous algebraic manipulation of factor and simplify. That numerator is factorable. So I can use the same strategy that I was using in the previous video to complete this limit, and that involves factoring the numerator. And the general rule is, if you see something that can be factored, then factor it. Just like up here in the beginning of the problem when we first started, if you can see something that you can expand, then expand it. All right, so let's go ahead and perform that factorization of the numerator. That gives me the limit as t approaches 0 of, now I'm just going to pull out that t because that's common to both the t squared and the minus 2t. And I'm left with t minus 2 on the inside, all over t. And what that does is creates a situation where I can cancel the t on the top with the t on the bottom. And there you go, my friends. That is exactly how you are going to get rid of that problem of the 0 appearing in the denominator. Because think about it. When I was trying that direct substitution back up here at the top, right? Back up here when I was trying that direct substitution, I was trying to plug in this 0 into that t, which directly caused the denominator to be 0. And that t in the bottom is precisely why direct substitution is not going to work. So now that I've canceled that t on the top and the bottom, now I can continue forward, and I'll carry through the limit one more time. And all I'm left with is t minus 2 over 1, which is just t minus 2. So that denominator is now taken care of. And it happened through an expansion. It was first an expansion, and then that turned into a factor and simplify. And now we've reached here. We're in the final steps now. Let me just buy myself a bit more room. All I need to do is finish up by saying, okay, now since that factor of t has been canceled, hey, I'm going to try to plug in that limiting value one more time. And when I do, I get 0 minus 2. Which is minus 2. And therefore, the limit is minus 2. If direct substitution fails, and you see something you can expand, then try expanding it. Make sure you are comfortable with the FOIL method, because the most common type of expansion is the square of a binomial. You might, in a rare encounter, have to cube a binomial, but I've never seen it get any more intense than that. So now we have two tools to consider when direct substitution fails: factor and simplify, and expand and simplify. Another twist for this type of problem arises when there is a sum or difference of rational expressions inside the limit. It is in this case that we can utilize our third algebraic manipulation that I call combining fractions. I'll show you guys all about it in the next video.